All right, so today we're looking at polynomials that we need to graph, but they're not in factored form. So we're going to have to get them in factored form. That's probably going to be our best bet. So you do know a couple of things. If I'm just looking at number one, there's some things that you know already. You know it's degree 3, so you know what the end behavior is going to look like, and the leading coefficient's negative. So before you even start, you have a good place, I don't know, a good idea of what's going on is what I'm trying to say. So normally, if you have a cubic function, the end behavior looks like that. However, because we have a negative leading coefficient, it's all going to flip over. So I know that my end behavior for this one is actually going to look like this. So I'm just going to leave that there to remind myself that's what I'm looking for at the end. Okay, and then if I take a look at my function, I'm just going to go ahead and try and factor it as far as I can, and then I'll take each of the factors, set them equal to 0, and then I'll be right, just like we were doing previously. So any hoosers, with this one, I would factor out probably a negative x squared, and I'm actually going to do it over here so I have a little bit more room. So if I take out a negative x squared, what would be left would be positive x minus 3. Okay, so now if I solve this, if I take each of these and set it equal to 0, I'm going to get my solutions. I'm going to get a positive 3 from this thing, and then from this, I'm going to get 0 with a multiplicity of 2. And so remember what that means. If I have an even multiplicity, that means my graph is just going to bounce at that point. It's not actually going to cross through the x-axis, it'll just touch it. Okay, so let's put some dots there. One of them at positive 3 and one of them at 0. And remember my end behavior, right? So I know that this side's just going to go up like this, and this side's going to go up like this. Okay, so now it's my job to just kind of fill in what's happening in between. So if I were you, maybe I would go ahead and plug in 1 and see what comes out. I'm expecting some positive value, right? Because I know my graph is going to bounce right there. So it's going to come and do something here. I don't know what, maybe something like this. We're going to find out, but it's not going to cross through. If it crossed through and I get a negative value, that doesn't make any sense here. So when I plug in positive 1, I should get some positive value back out. Okay, so let's be careful. If I plug in 1 right here, remember you do the exponent first. So 1 cubed is 1, and then I take the opposite. So that's negative 1 plus 3 times 1 is just 3. So I get a positive 2. Okay, so that makes sense. You can go ahead and plug in 2 if you want to. I will, because it's pretty fast. So 2 cubed is 8, so that'd be a negative 8 plus 3 times 2 squared is 4. So that would be a 12. 3 times 4. So I'd get 4. This gives me a little bit better idea of what's going on right there. Okay, so there is my first graph, and it's everything I thought it would be. Cubic function. I have that end behavior. It turns twice. It can't turn any more than that, so this makes sense. Okay, let's go ahead and try the second one. Okay, so this one, again, I'm going to go ahead and factor out whatever I can. And this time I could take an x cubed, and I'd be left with x plus 2. So when I go to solve this, that means that I'm going to get negative 2, and then I'm also going to get 0 3 times. So 0 with a multiplicity of 3. All right, so I know I'm crossing at negative 2, and then what's happening at 0? If the multiplicity is 3, does it bounce? Does it cross? What does that mean? It's going to cross. Anytime the multiplicity is odd, it crosses. So even if the multiplicity is 1, right, that only happened one time, I'm crossing through the x-axis there. It's only when the multiplicity is even that it's going to bounce. Okay, so let's talk end behavior. So this thing is to the 4th. So that means they're both going to go up together since my leading coefficient is positive. So you're up, and then I would just go ahead and take negative 1, plug it in, see what comes out. So negative 1 to the 4th would be a positive 1. And then that's going to turn, oops. I'd have negative 1 cubed is negative 1 times 2 is a minus 2. So I have 1 minus 2. I'd get a negative 1. Okay, now I'm not totally sure if this graph goes bloop like that, or it could do something like this. Okay, and I wouldn't know that unless I went in and I plugged in some more values. So remember, we are just sketching, so I'm totally okay with you just doing this. And if you want to double check it on Desmos, or if you happen to have a graphing calculator, that's a great way to get more detail what's happening in between those values. Okay, maybe we'll do one more together. Let's pick a good one. How about oh, okay, 3 is not so bad. All right. So this one, I would factor out a negative x, and then you'd be left with x squared plus 6x plus 9. Okay, and now I can continue to factor what's in here. That's a quadratic that does factor. So that would just be x plus 3 and another x plus 3. So what does that mean? When I go to find my solutions, I would have 0 from this, and then I get negative 3 twice. So I'd say negative 3 with multiplicity of 2. All right, go ahead and graph it. So I have it 0 and I have it negative 3. And if that multiplicity is 2, remember what that means. I'm going to bounce at that value. Okay, it's not actually going to cross through. Let's go back and talk end behavior. It's to the 3rd, so that would normally be like this, but because it is a negative coefficient, it's going to be the reverse. Okay, so this one's going to go off and this one's going to go off. So let's plug in a value or two in between and see what comes out. So I'll just do negative 1 real quick. So negative 1 cubed is negative 1, but then you take the opposite, so it actually comes out as positive 1. Negative 1 squared is positive 1 times negative 6 is negative 6. And negative 9 times negative 1 is now positive 9. So that's going to come out to be 4, positive 4. So negative 1, 4. Okay, I'm going to plug in negative 2 as well, just because I want to get a little bit more detail. So let's see, negative 2 real quick. So negative 2 cubed would be a negative 8, but then take the opposite. So now that's a positive 8. Negative 2 squared is 4 times negative 6 is a negative 24. And then negative 9 times negative 2 is now positive 18. So that's going to get me what? That's a negative 2, positive 2. Which makes sense because remember right here at that negative 3, it was going to bounce. So it's going to bounce up and do something along those lines. Okay, so I hope you find this helpful. Give it a shot. Let me know if you have any questions.